Hey guys, we've got an applications of differentiation question here today where it's asking us to find the equation of the tangent to the curve y equals x squared minus x cubed all over x to the power of 4 at the point where x equals -1. Okay, well the first thing we're going to do when we answer any of these sort of problems is we're going to get the function when x equals -1. So we want what y is equal to when x is equal to -1. So first of all, let's figure out what the function is equal to when x is equal to -1. Okay, so this is going to be equal to -1 squared, take -1 cubed over -1 to the power of 4. Okay, so -1 squared is +1, minus -1 cubed is -1, so minus -1 is going to be +1, all divided by -1 to the power of 4 is just +1. So this is equal to 2. So the point where x equals -1 is actually going to be the point -1, 2. Now that's going to be important to us later on when we're solving this question. Okay, so what we're going to do now is we're going to rearrange this equation so it's a little bit easier to differentiate. So we're going to have y is equal to x squared over 4. Oh, sorry, x squared over x to the power of 4 minus x cubed over x to the power of 4. Now this is going to be equal to x to the -2 minus x to the -1. Cool. So this is the function, or this is the representation which we're going to be differentiating here. So we're going to get a dy dx is equal to -2 divided by x cubed. Now the way I've done that is I've times the -2 down. I've reduced the power by 1 to be -3, so it's made the x have to go down to the bottom to the power of 3. Now this is going to be plus 1 over x to the power of 2. The reason it's 1 is because the -1 times down, so negative times negative is a positive, hence plus. Then drop the power by 1, -1 becomes -2, which takes it to the bottom with the power of 2. Now, we're going to evaluate this derivative at x equals -1. So we're going to go dy dx evaluated when x is equal to -1 is going to be -2 over -1 cubed is still -1 plus 1 over -1 squared is 1. So we're left with 2 plus 1, which is equal to 3. So the gradient of our tangent, or we'll call it m, is going to be equal to 3. Now, the structure of our tangent line, the tangent to the curve, is going to be equal to y equals mx plus c. And this is the gradient intercept version of the linear equation. Now the gradient, which we've just worked out, is this m here. And this is going to be our y-intercept. Now, what we're going to do is we've found the gradient, which we can just plug straight into this formula. So we're going to have y is equal to 3x plus c. Now what we can do is we can substitute in the point -1, 2 into this formula and solve for c, because this linear equation has to also go through that point. So we're going to have y is equal to 2 equals 3 times -1 plus c. 3 times -1 is -3. -3 plus something, which equals 2. C is going to have to equal 5. So we can then say, therefore, the tangent is equal to y equals So, basically what we've done here is we've figured out what the y value is, or the corresponding y value at the point x equals -1 of our function. So we can actually get a point where the tangent line is going to intersect the curve. What we then do is we rearrange this formula so we could get it to a type of function which it was easier for us to differentiate. We then differentiated it and then evaluated the differential at the point x equals -1 to get the gradient of the tangent, which we worked out here. Now, what we then did is we then substituted our gradient into our tangent formula and then inputted the coordinates of the point where the tangent and the curve touch. Once we've done that, we've only got one variable left in our point-intercept linear function, and if we only have one point left, it allows us to solve for it. So we could just solve for c equaling 5. Once we've done that, we've got all of the information we need to construct the equation of the tangent line, and then the question is solved. With these sort of questions, the way that you solve them, the way you go about them is almost exactly the same every time. I've got quite a few videos on my channel about this one. If this video helped, give it a like. Subscribe to my channel if you want to find any more. I release new videos, trying to get them most weekdays. So, yeah, I hope you enjoyed it, and I'll see you again next time.